lesson, we looked at perimeter, and perimeter was the distance around a shape. So it doesn't matter what kind of shape we looked at, it was just the distance around the shape. So we just added the sides together. Whereas area is the space inside a 2D shape. Okay, so that's just a normal shape that we see on a piece of paper. Our main shapes are circles, rectangles, we've got squares, and our triangles. Those are the 4 shapes that we deal with when it comes to perimeter and area. And then, as you know, we combine those shapes, but the combination shapes are made up of these 4 shapes. So if you understand the basics of these shapes, you'll be able to handle them when they're all combined. Okay, when it comes to area, our units are squared. So it's millimeters squared, centimeters squared, meters squared. If we get there, kilometers squared. Whereas perimeter, it was just the units as is. Okay, then we go on to formulas. Now, for the most part, you will be given the formulas in a test. They might not give you one for a rectangle per se, because that's pretty straightforward. Area formula for a rectangle is our length times breadth, or you could say length times width. Breadth and width mean the same thing. Okay, with a square, you can say side squared, or you could just say length times breadth again. If you look at the square over here, if you want to call it different, I mean, at the end of the day, they're the same number. Circle, our formula is pi r squared. So remember, with circumference, which is the perimeter of a circle, we had pi times d, or 2 pi r. Now, quite often people get confused between these 2 formulas. When we're dealing with area, the radius is squared. Okay, when we're dealing with circles, as you can see, we're always using pi. So if pi is involved, you know we're dealing with circles. And then triangle formula is half base times height. For the most part, you should know these formulas off by heart. It's the volume and the surface area ones that can get a little bit tricky and long. Okay, so keeping these formulas in mind, now's maybe a good time to take a screenshot, or if you've got them down, because I want to just test to see if we understand how to use these formulas. Okay, so let's have a look at exercise 1. We're starting with rectangles. I'm going to give you guys, I think a minute will be sufficient to quickly work out the area of these 2 rectangles for me. Starting off nice and easy. If you have some answers, you're welcome to share them. If you would like to tell us how you got it, maybe speak to us while it's nice and easy. We'd love to hear your voices.
And I think speaking to us might be a little easier, considering some phones don't have that other thing we should be adding to the answer.
Yeah, especially when it comes to our units. Anyone want to raise a hand? Yeah, no, still easing in, still warming up.
Look at Siwa.
Siwa found the loophole.
She's like, nope, I will type it.
Well done, well done. Nice, Oratile, Naledi, and Siwa. Thank you for your answers. Anyone else? Welcome to add. Let's quickly go through it. Rectangles, nice and easy. We've got our length of 6 centimeters and our width of 2 centimeters. You don't need to rewrite the formula. I just do it out of habit. It just helps me. That also, by rewriting it the whole time, helps me learn them. Okay, so 12 centimeters squared. Don't forget the squared. If you don't give the correct unit, sometimes you do get penalized. Sometimes you get lucky and they give you an extra mark for the unit. So they might give you a mark for the 12 and the correct units. So really make sure that you concentrate with units, especially in the whole measurement section, because sometimes you get a mark for the unit, which is a nice free mark. Okay, the second rectangle, we've got our length and our width. So we are going to times the 2 and we get 15 millimeters squared. Okay, a question like that will be about 2 marks normally for your method and your answer. Good, looks like we all did well there. All right, starting off with triangles. The next question. I'm going to give you a couple of minutes. Okay, do we have some answers? Let's see them.
Drop them like they're hot in the chat, guys. Don't be afraid.
Nice, nice, nice. 16 centimeters squared. And I see question 2 is also popped up in there. And some of you again, 24 centimeters squared, which is correct. Nice, Tabile. Nice, Latimba. Ukamo, nice. Okay, so nice and easy. Half base. And we've got a height over here, so half base times height gives you 16 centimeters squared. And number 2, we get an answer of 24 centimeters squared. Nice. Let's have a look at our next one, circles. I do keep forgetting to put this in, but it's always implied. Please use pi is equal to 3,142 because that's how they're going to ask you in your exams. Always. We hardly ever use the pi button. So whenever you need to substitute pi into a formula, please use 3,142 as your value for pi. Not always, but it does make a difference with your decimals. Carmel, you said, what about the second one for the triangles? Did you? Can you see the answer now? Deja. Okay, so I see some answers popping in. Okay, let's wait for some more answers to feature.
Vitumelo, please remember to keep your mic off.
Okay, guys, let's look at circles. They have given us the radius for each circle, so we don't need to do anything. Let's say, for example, they gave us a circle and they told us the diameter. And now we know the formula is pi r squared. So we need the radius. All we need to do is say radius is equal to 12 divided by 2. Because remember, the radius is half of the diameter. So then we just work out the radius quickly. Didn't need to do that now, but we will need to do that later on. Okay. Cool. No problem, Siwa. Just want to check. I see we're getting some different answers here. All right, so using our formula, area is equal to pi 142 times by radius squared. And that will give you an answer of 78,55. So for the most part, we always round to 2 decimal places unless stated otherwise. So unless they ask round to the nearest centimeter squared or round to the nearest 10 centimeters squared, we always use 2 decimal places as our rounding point. Okay, second circle. Our radius is 10, so we square the 10 times about pi and we get 314,2 inches squared. So letter 5 is the radius. Diameter is from one edge of the circle to the other. So they've given us the radius for each. So let's just quickly remind ourselves. From the middle to the end point of the circle, that is the radius. So it doesn't matter where. It could be there, that way, that way. Okay, that is the radius from the middle, okay, to the end. And it's just, and then diameter is from one edge of the circle to the other. That is our diameter. Okay, do we have any questions? Because I see we got quite a few different answers here. Let me know. Okay, are we feeling confident with our basic shapes? Let me know in the chats. Can we try a quick challenge question? Give me a thumbs up. Let me know which shape is still bugging you, if there is one, or you're okay for now. So I always like to start off teaching the basic shapes and just getting comfortable with the shapes, so that we are prepared for when we combine the shapes together, we can understand it a lot easily. Okay, yo, Oratile, next, straight up. Okay, so before I go to the challenge, I want you guys to not freak out. It is possible, based on what we have learned, to work out the area of these shapes. Some of you will be like, oh, easy peasy, but don't freak out, okay? Let me quickly create some space here. Oh, can't do it that way. Okay, I didn't want to show those other two shapes just yet. Okay, we need to work out the area of these two shapes. Does anyone have an idea of how we are going to work this out? Because it's not a square, it's not a rectangle, definitely not a circle or triangle. Nice, Siwa. We can, however, separate them into shapes we know. We know rectangles, we know squares. I can make rectangles out of this shape. So you can choose which way you want to split it up. So the first way that pops out to me is splitting it up this way. So I have one rectangle over here, a second rectangle over there. So now I can work out the area of the first rectangle, work out the area of the second rectangle, add it together, and voila, there is your total area. Okay. However, we do have a missing side over here, which is quite important to work out the area of rectangle 1. So let's have a quick look. We know that this whole length is 10 centimeters. So that means this whole length needs to be 10 centimeters. But we know up until this point, it is 5. So to make up the rest of the 10 centimeters, this must be 5 centimeters over there. We did have a look at finding the missing sides last lesson, and you guys were quite confident. Okay, so if you're unsure of how to set it up, I just label it 1. I say area is equal to length times width or length times breadth. The length of my first rectangle is 5. Length is the longer side, L for longer side. Okay, and our width is the shorter side. So our area for the first rectangle will be 15 centimeters squared. I then work out the area of the second rectangle. Length is 7, width is 5, which gives you 35 centimeters squared. So my total area is 15 plus 35, which gives you 50. Okay, if that doesn't make sense, let me know. Otherwise, please try question 2 for me.
Leah would like for you to explain number 1 again because the network went off.
No problem. Okay, so Leah, we're dealing with an irregular shape. So it's not our standard rectangle, square, circle, triangle. So in order for us to actually work out the area of it, we need to split it up into shapes that we do know. We know those 4 shapes. Out of those 4 shapes, we can see that we can make 2 rectangles from it. So I split them up. And as you can see, I had to work out this side over here. And that ends up being the length for this rectangle, and I times by the width of it. And then I did the same with the second half. And as you can see, I've labeled each rectangle when I did my working out. Does that help? Just so you guys are aware, you could also separate the shape this way. It really is up to you. Okay, let's have a look at shape 2. Now again, it all depends on how you separated it. Do we have, yes, Siwa. Does anyone want to just give us your answer as well? Let's just see if we're close. Siwa is spot on. Norm Claire, yes. Yes, yes, yes. Emily Claire, yes. Okay. But you guys have got this. All right. So pops out to me, I would split it up this way. So I've got 1 rectangle here, 1 rectangle over here. So my working out for rectangle 1 is length times width or length times breadth. My length is 8 times 6, which gives you 48 millimeters. Oh, I don't know what happened there. Squared. Rectangle 2. Okay, so I needed to work out the missing side. We know that the full length should be 10. If up until this point is 6, to make up the 10, this side would have to be 4, because 6 plus 4 will give us our 10. So it becomes 6 times 4, which is 24. So the total area, we add it together, which gives us 72 millimeters squared. Yeah, I think I see most of us were used to centimeters, so just make sure we check out the units. And I have been changing them a lot. I've even included imperial units like inches and yards, just to keep things interesting, get us in the hang of things, especially when we are working with the imperial system. Okay, looks like you guys understand that. Let's try these 2 shapes. How do we get the 4 again? Let's quickly go back. So we can see from this side is 10. So that means from here to here must be 10 as well. But we know this section is 6. So to make up the 10, I can say 10 minus 6 to give me the remaining part over here. Okay, I hope that helps. Does it help, Naledi? Was it Naledi that asked? Yeah. Perfect. Okay. So just quickly, when it comes to circles, we know that our formula is always the same. We just need to adjust it sometimes based on the size of the circle. So if I am looking at a full circle, it's going to be pi r squared to work out the area. But in this instance, I'm looking at half a circle, a semicircle. So just like we did with circumference on Monday, I have to adjust the formula to suit the shape I'm looking at. So now I'm not working out a full circle, I'm working out half a circle. So you can either take your answer, divide by 2, or we just times by half. Take our formula and times by half. If for some weird reason there was a quarter circle attached to the shape, you do the same thing, pi r squared times by 1/4. And then the last possible size is a 3/4 circle. So just so that you are aware, you keep the formula as is, but you just times by the size of the circle that you're looking at. So it can either be full circle, so formula stays the same. If it's half a circle, you times by half. Quarter circle times by quarter. 3/4 circle, you times by 3/4. Okay, so very, very, very similar to what we did with circumference. It only applies to circles. So you don't have to stress about worrying about this with any other shape. Okay, so keeping this in mind, can I ask you guys to try A quickly? I just want to go back up for a quick screenshot. Okay, let's try A. Okay, do we have answers for question A? Oh, Ben, welcome. Haven't heard from you in a while. Okay, so I'm getting half the answer from Ben and Bukamo. Remember, you need to add it to the area of the semicircle. Yes, Siwa. Okay, so if we're looking at the semicircle, we're using pi as 3,142 times by. Okay, so here is something to just make sure of. Our diameter is 4 because remember this line is equal to this line over here. That's how I know it is 4. And if I had to complete the circle, we can see that that is my diameter. But for the formula, we need our radius. So you need to work out the radius. So you're going to say the diameter of 4 divided by 2. Gives you an answer of 2 centimeters. Now you do get a mark for showing this, so please include it, even if it is to the side. Okay, that's preferable, put it to the side, but you do get a mark for realizing you need to work out the radius and then actually doing it. So always show this step on the side. Okay, so now that I know my radius, I can put that into the formula. So it is 2 squared, and I'm timesing by half because it's half a circle. And that gives me an answer of 6,28 centimeters squared. I then have a second part of the shape, which is my rectangle. That's my second part. So the area is 6 times 4, which is our length, times breadth, which gives me 24. So therefore, our total area, we add 6,28 plus 24 gives us 30,28, and dealing with centimeters, so centimeters squared. Okay, nice. So don't forget, we need to add the two together afterwards. So there was quite a lot in that question. Having to realize we must work out the radius and then doing two separate calculations, but then remembering to add them at the end. Okay, let's have a look at question B. We have a triangle and a square, it looks like. Okay, so let's just make sure we have all the necessary sides. So with a triangle, our formula is, so that's shape 1, shape 2. Triangle is area is equal to half base times height. Now, normally, based on what we did on Monday, we looked at perimeter. We would need this hypotenuse side. But do we need the hypotenuse side now? Okay, so we don't, because we have our base over here. Oh, these colors are actually deleting the line. Let's not do that. We have our base, bottom here. And we have our heights on this side here. Now we might just need to work them out. So height is 12. And the base of our triangle, we know that from this point to this point is 17. But from this point to this point, it is 12, because we know from here to here is 12. So this extra little bit must be 5. So I'm going to do that again. So I've worked out the height of my triangle, because remember, whenever we're looking at a right angle triangle, it's always the base times our perpendicular height. Okay, perpendicular means it's on the other side of the right angle. Okay, so I've got the height based on my information with these lines. We know that it's a square, so the height must be 12. Then I know from this point to this point, it is 17 centimeters, but I just need this little bit. I know because this is a square that this section is 12. So that means this top part must be 5 to give me the total of 17. Okay, so it's going to be half base, which is 5 times height, which is 12. Nice, Siwa. Okay, when we work that out, that gives us the area of our triangle. And that gives you an answer of 30 centimeters squared. Shape 2 is a square, so it's nice and easy So it's length times length, or side squared. The side is 12, so you can say 12 squared, or 12 times 12, which gives you 144. So the total is 30 plus 144 equals 174 centimeters squared. Now, if you don't know how to work out the triangle, still do the square side of things, because you'll still get marks for that. So don't just leave it completely. Do the shape that you can do still. If you simply cannot remember what to do with the triangle. Okay, don't leave it blank. You could still do the square part, which is half of it. Okay, so how are we feeling about combination shapes, combining the 4 shapes that we know? Better than perimeter or not so much? Let me know in the chat. Thumbs up. Ready for the next thing? Yeah, we definitely are going to practice more. Don't stress. Okay, so just quick rundown. Question B, we have 2 shapes, triangle and a square. Now, we know the formula for triangles, half base times height. Okay, our height is always the perpendicular height on this side over here. And we can tell that that is 12 centimeters because they're showing us that the shape is a square. So I've got the height. Now I technically also have the base, which is what I need for my formula, but I just need to work it out. I know that this part is equal to 12, and they're telling me this whole length is equal to 17. So I take 17 minus the 12, which gives me 5 over here. So I've just split up the 17 to help me get the triangle base and the square base. I then use my 5 and my 12 in my triangle formula over here. I then just say 12 times 12 for the square because it's square and it's side squared, or length times breadth. Okay, so see here just quickly again, because we're looking at a square for our second shape. So it's 12 times 12, or you could say 12 squared because it's a square. Okay, or side times side. I'm going to take a screenshot of which question? This question? Or do I need to go up some more? Apologies, don't know your name. It's coming up as iPhone. Perfect, my lady. Hopefully that helped. Okay, we're done with screenshots. So, granted, our lesson on Monday doesn't go over what I've planned. We can practice area and perimeter of these shapes on Wednesday next week. Okay, granted, it all goes to plan. Okay, so now we are going to look at surface area. So again, we're looking at 2 simple shapes that we know, all the shapes that we know. Surface area is the total area of all the exposed surfaces of a 3D object. So this whole time we've been looking at 2D objects that we can actually draw on a piece of paper. But surface area, 3D objects, or actual objects, real life objects that have all the dimensions. Okay, again, because we are dealing with area, our units are squared as well. Oh, and then I go and write cubed. Okay, centimeters squared, meters squared, kilometers squared. If I give you imperial units, yards squared, etc. So our units are squared because we're still dealing with area. And our two core shapes are rectangular prisms and a cylinder. So good examples, everyday life examples of a rectangular prism could be your eraser in your pencil case when it's brand new, hasn't been used yet. It's a perfect rectangular prism shape, or a tissue box. And a cylinder, good example is your glue, okay, or a toilet roll. Okay, we need to work out the surface area. So that means we are working out the area of every single face. So this is the only, it is a square kind of shape that I could find. But as you can see, it's got a top and a bottom. 1, 2, 3, 4 sides. So there's 6 sides in total to a rectangular prism. Okay, a cylinder has a circle at the top, circle at the bottom, and then we've got the height going around it. So let's look at the formulas quickly. For a rectangular prism, it's quite a long one, but it's not a hard one. It is 2 times length times width. Okay, so that works out. So if you think about a tissue box, the top of the box, my length times my width. And I say times 2 because there's a top and a bottom of the tissue box. Plus 2 times length times height. So if we look at the front of the tissue box and the back of the tissue box, the front, we've got our length and our height, and I times it by 2 because it's the front side of the tissue box and the back side of the tissue box. So that's 4 sides we've accounted for now, plus 2 times width times height. So that would be my side of the box, the width times the height, and I times by 2 because there's a side on this side and on the other side. So if you do forget the formula, just look at the shape and you can literally go and calculate the area of every single side and just add it together. So if you look at a tissue box, work out the area of the top of it, work out the area of the bottom, the 2 sides, the front and the back, add it all up. They're all rectangles. Okay, cylinder is, because it's got circles involved, 2 pi r squared plus 2 pi r times height. So this first part of the formula, as we will recognize, this is the area of a circle. I'm timesing it by 2 because I have 2 circles in a cylinder. I have the top and the bottom. So it's the area of a circle times by 2. So that's my 2 circles, part of the formula. And then this half of the formula works out the rest of the area, okay, of your cylinder. So I've just explained the formulas just to maybe give you a better understanding of why they are like this, how they work. They are given to you in an exam. Okay. So based on time, we are going to try, I think, let's start with one of each of these and then see if we have more time. So using these formulas, can I ask you to please try question 1 for me? If you work quickly, you can try question 2 and I'll just check your answer and then we're going to try these cylinders quickly. I will continue with this next time, so don't stress. Let's just focus on question 1. Do we have answers? Also, especially if you're working with millimeters, you can expect big answers when it comes to surface area and volume, so don't freak out if that's the case. Okay, so all we had to do was substitute into our formula. 12 is our length. So if we look at the front of our shape, length is our long side and our height is the 7 and the width is the 4. Again, though, if you mix up the dimensions, it's not going to be the end of the world because we times in everything together. So remember, when you times in everything, it doesn't matter what order you put it in, you'll still get the same answer. So don't worry if you do get confused. So it ends up being 2 times 12 times 4 plus 2 times 12 times 7 plus 2 times 4 times 7. And if you put that all in your calculator, you will get an answer of 320 inches squared. Okay, so just quickly, the first part of the formula works out the front of the shape as well as the back side. Okay, the second part works out, sorry, I did that the wrong way around. The first part of our formula works out the top of the shape and the bottom. The middle part of the formula works out the front side of your shape and the back side, and then the last part of the formula works out the two sides. Okay, so all we're doing is working out the area of a rectangle 6 times, but remember, all these rectangles are slightly different sizes. Okay, so it's just, as you can see, area of a rectangle times 6 times. They just got different dimensions. All right, let's have a look at the cylinder. Let's look at the first one. It's got a radius of 20 centimeters and a height of 42 centimeters. When you've got your answer, please share it in the chat. Okay, 2 different answers here. Okay, still some different answers, but I'm seeing some right answers as well. Let's have a look. So now we're just substituting our dimensions into the formula. So it is 2 times by 3,142 times our radius, which is given to us. We don't need to work it out. So it is 20 squared plus 2 times pi times 20 times 42. Nice, nice. I'm seeing the correct answer. So now if it does help, because there's a lot to put in your calculator, maybe do the first part, okay, work it out, then do the next part, and then add it together. It is beneficial to do it that way, but I know that we all prefer just to put it in the calculator and get our answer straight away. But now we are getting slightly off answers, so maybe just check. It should give you 7,792,16 centimeters squared. Oh, which I see most of us are getting. Those of you that did not get this answer, please just check that you've substituted the correct numbers in and that you're times in when you need to be times in. The only time you are adding is over here in the middle. And like I said, with surface area and volume, don't be afraid if you get big numbers. Nice, nice. Okay. So in the next lesson, we'll continue a little bit more with surface area. It can get a little bit harder than this. We have to adjust the formula slightly again for certain things. But this is it. These are the two shapes we focus on with surface area. So we'll be dealing with surface area and volume on Monday, same time, same place.